Hi everyone, this is Yashika and today we are going to learn about dimension reduction. So, what dimension reduction is? Basically, it is a process or we can say set of techniques which is used to reduce the number of features in a data set. While in this, what we do is we preserve the most important features, information with us, and discard the rest. So we can say the simply its aim is to simplify the complex data set, and how do we do that? By transferring them into lower dimensional space. We make them easier to analyze, to visualize, and to interpret when we reduce its dimension. So, the most important goal of dimension reduction is to retain as much as relevant information as possible while eliminating the rest, which are less important and less informative for us. We can say it is dimension reduction is used in various other fields like data analysis, machine learning, signal processing, and image recognition, etc. So like it has very importance. So that's what we are going to discuss next. Importance of dimension reduction. So as I said, it is used in various field today, like in data analysis, machine learning. So some of its important features are faster processing, improved visualization, and efficient storage. So in faster processing, we reduce the number of dimension in data set, and by reducing those dimension, we can speed up the data processing and analysis also. We speed up this, and we can also say with fewer variables. When we have less variables, algorithms can compute results very quickly, so we can get results very fastly. Also, um, we can also say that such things are also used in model training and like prediction and optimization. So another importance of dimension reduction is improved visualization. So we can say that for dimension reduction, with dimension reduction, we get high dimensional data, representation of high dimensional data. Like we get better visualization here. So how we transfer the complex data set into lower dimensional spaces so that it becomes easier for us to plot and interpret the data visually. So there are several techniques used for this, such as PCA and TSNE. So these are the common techniques which we will discuss later. Another one is efficient storage. So since we know that in dimension reduction, we basically reduce the amount of data set, like we convert them smaller so that we have now compact data representation. We don't have to represent entire thing, just the important part. So this also help us in saving memory, and like uses less memory, and saves the disk space also, by making the data more manageable and accessible. So yeah, that's another one. So now these are the techniques used for dimensionality reduction, which is like these are the common techniques, which are principal component analysis, linear discriminant analysis, multidimensional scaling, and manifold learning. So let's go ahead and discuss each one of them in detail, starting with principal component analysis. So what it is? So we can see that PCA is a linear dimensionality reduction. So here we like reduce the dimensions linearly. So the idea behind this is that it simply helps us in simplifying complex data sets by identifying patterns and reducing the number of variables without losing important features. So yeah, that's what here that's what written that is what written here. that PCA is like a linear dimensionality reduction technique that identifies the most informative directions and reduces them accordingly. So how it works? So first step is that it identifies the direction in which the data varies the most, called principal component. So first of all, we identify the directions where the data is varying. Then it reorients the data along these principal components, making them into new set of axes. So then after identifying it, then it reorients it. Now it also after this it ranks these components by how much of the total variability in the data they explain, like what is more important, what is not important, and accordingly it selects the top component that capture the most of the variability of the data in the data, जिसमें ज़्यादा से ज़्यादा वो कैप्चर कर पा रहा है उसको वो सेलेक्ट कर लेगा एंड देन इट कीप्स दैट एंड डिस्कार्ड द रेस्ट. सो इन द रिजल्ट वी गेट टॉप कंपोनेंट. हमको टॉप कंपोनेंट मिल जाता है जिसमें वी गेट एवरीथिंग लाइक वेरी इंपॉर्टेंट फीचर्स, वी गेट दैट वन. एंड we also have lower dimension now. We don't have high, very much like big dimension as we had for the original data. So how application where it is used. So yes, here it is written, it is used in image compression, feature extraction, data visualization, and etc. Now comes the another technique, linear discriminant analysis, LDA. So basically LDA is an approach which is used in supervised machine learning. So here basically we separate multiple class with multiple features through data dimensionality reduction. And this technique is very important in data science, as we know it helps in optimizing machine learning model. So yeah, here we basically separate the data in different classes. We classify the data and find the linear combination and the features of the best separates of two different classes or groups in the data. So it works on supervised learning, as I said. And the application, it is basically LDA is like commonly used in face recognition, text classification, and also it is also used in like pattern recognition, etc. So the another technique is multidimensional scaling, MDS. So this is kind of a non-linear dimensionality reduction technique which preserves the pairwise distance between the data point. So which means that this is a technique that creates a visual maps of the data points based on their similarity and their differences. So here it means that it keeps the similar points together and different points far apart in a lower dimensional space. So like it is like making complex data easier to understand and interpret. So here we can use this technique in similarity preservation also. So that means that it ensures that the similar data points remain together and close in a reduced dimensional space, which I said earlier. So it also helps us in creating 2D or 3D visualization for high dimensional data, also revealing its underlying structure. So it's basically it preserves it, it helps in visualization, and it is like a good technique to for what we say it putting the data points similar together and different data far apart from it. So steps basically it involves that ये pairwise distance को calculate करती है between data points, and then it maps the distance into a lower dimensional space, and the result is the visual representation of the data points. और इसकी एप्लीकेशन है कि कॉमनली साइकोलॉजी, जियोग्राफी और मार्केटिंग जैसी फील्ड में यूज़ करते हैं. Now comes manifold learning. So basically it is a type of non-linear dimensionality reduction technique which aims to uncover the low dimensional structure or like manifold or and embed into high dimensional data, which are embedded in high dimension data that not embed into. It helps us to uncover or find or identify those low dimension data structure which are there in high dimensional data but we cannot like see it properly. So basically we can, simple example we can take is, we take a piece of paper and like we crumble it into a ball, and now even though this piece of paper is in a three-dimensional space, but it also kind of contain two-dimensional data structure, 2D information. So manifold learning techniques is like helps us to uncrumple the paper, or like we are trying to learn the lower dimensional, the 2D dimensional surface, or which are hidden under the हाई डायमेंशनल स्पेस. सो वही कि जो भी टू डायमेंशन छोटी डायमेंशन की चीज़ हाई डायमेंशन में छुपी है, हम उसको बाहर निकाल के उस पर हम लोग लर्न कर रहे हैं, उसको हम लोग समझ रहे हैं. दैट इज़ व्हाट वी आर डूइंग इन मैनिफोल्ड लर्निंग टेक्निक्स. सो ये ग्राफ बेस्ड मेथड है. हियर वी हम लोग इसमें आइसोमैप और लैप्लेसियन जैसे ग्राफ्स हम लोग बनाते हैं टू लाइक फाइंड द लो डायमेंशनल एम्बेडिंग्स. और ये यूज़ करते हैं हम लोग डीप लर्निंग में. इसमें लाइक डीप लर्निंग बेस्ड टेक्निक्स इसमें हम यूज़ करते हैं, जैसे कि ऑटो एनकोडर्स विच ऑल्सो हेल्प्स अस इन एफिशिएंट नॉन लीनियर डेटा रिप्रेजेंटेशंस. So yeah, that is what manifold learning techniques are. Now comes the application of dimension reduction. So there are several applications. Some of our image processing, video analysis, speech and audio. These are like main applications. So through dimension reduction we are able to like do the proper इमेज कंप्रेशन, सेगमेंटेशन एंड फीचर एक्सट्रैक्शन. हम लोग जब हाई डायमेंशन को हम लोग जब रिड्यूस करके स्मॉल डायमेंशन में ले आते हैं तो हम लोग उससे इमेज का कंप्रेशन भी करते हैं. हम लोग उसको तोड़ भी सकते हैं सेगमेंट्स में. एंड ऑल्सो हम लोग कुछ अगर स्पेशल फीचर्स वहाँ से हमको किसी भी इमेज के चाहिए तो हम लोग उनको एक्सट्रैक्ट भी कर सकते हैं. तो दिस इज़ लाइक हम लोग इमेज को प्रॉपर पूरी तरीके से वी कैन प्रोसेस image. So video analysis can also be done with the help of dimension reduction. In video analysis we can like summarize the video, we can do object tracking and also activity recognition. So like summarization में basically वही करते हैं हम लोग कि की फीचर्स को एक्सट्रैक्ट करते हैं सीक्वेंस में और उसको लाइक रिप्रेजेंट करते हैं एंड देन वो उसको प्रोवाइड करते हैं सामने वाले को. तो बेसिकली हमें एक समराइज वीडियो मिल जाती है, समरी मिल जाती है उसके. सो ये हम लोग PCA के थ्रू कर सकते हैं. ऑल्सो हम लोग ऑब्जेक्ट ट्रैकिंग कर सकते हैं, मूवमेंट ट्रैकिंग, मोशन ट्रैकिंग, ये सब चीज़ें भी हम लोग वीडियो एनालिसिस में कर सकते हैं. आफ्टर दैट देयर इज़ स्पीच एंड ऑडियो. सो हम लोग स्पीच रिकॉग्निशन, म्यूज़िक इंफॉर्मेशन रिट्रीवल और audio event detection that can also be done through dimension reduction. So speech identification करने के लिए भी वही टेक्निक्स लाइक PCA, LDA को यूज़ करते हैं, जिसको हम लोग सिस्टम में लगा देंगे जिससे वो फीचर्स ऐसे निकाल ले कि जिससे हमें सिग्नल्स मिल सकते हैं, जिससे पता लगता है कि किसकी कैरेक्टरिस्टिक्स के साथ किसकी यूनिक कैरेक्टरिस्टिक्स है, उसको कैप्चर करते हैं. एंड देन इंडिविजुअल के साथ हम लोग उसको लाइक कनेक्ट करके वी कैन ऑल्सो लाइक प्रॉपरली आइडेंटिफिकेशन वी कैन डू, स्पीच का रिकॉग्निशन ऑल्सो, और वही क्लासिफिकेशन भी. तो या दैट्स an introduction, and to this we have come to the end, and that's all about dimension reduction. Thank you so much.